Good evening. How's my audio?
That's fine.
Yeah, okay. Got a little bit of a different setup here. I don't know if you can tell my video quality is maybe a little bit better, maybe? I don't know. You tell me.
Worse, if anything.
Yeah. Come on. You can see every beautiful pore on my face now, can't you?
Yeah. It does look good. Look like Peter Mansbridge on the National.
Yeah, nice. But unfortunately, with my new setup in my professional studio here, my cell phone may drop to the ground. It's just perched, kind of wedged between the top of the laptop and a speaker. So, you know, if all of a sudden you hear a loud thunk, it's either me or my phone. One of the two has dropped to the ground. So.
Oh.
No audio? Who was that?
I think he's saving it for later on. I think Kevin's supposed to drop in. I haven't seen him yet, and I know Ken's not. And there's Cherry. Who else is missing? Oh, Klaus is not here yet either.
Wow.
It's Bob Dylan. Bob Dylan.
Yeah. How's that song go? You know, where he's got the things.
So, Dave, how are your therapist sessions going? That kind of figures. I shouldn't have even asked. I think we should do a Rorschach test on Dave. See what he sees in various blots.
Boy, it's a good thing Al's got his name on his profile there because I don't recognize him. Okay, should we get started or do you want to wait a couple more minutes?
Yeah, notice how attendance is dropping off.
Pardon?
Peter, notice how attendance is dropping off?
Yeah.
Including Ken. Where's Ken? Is he at the camping?
I don't know. He didn't say. He just said he couldn't make it. I know Kevin's up north, and he said he was going to come in, likely not with video, although he had something to talk about tonight. But so I do expect him. Not too sure what's happened to Klaus. If I was Klaus, I'd be phoning Frank for that meter.
Haven't heard a word from him.
Pardon me?
I haven't heard a word from him.
Okay. All right. Well, we might as well get started. Well, good evening, everybody. As I was mentioning a minute ago, Ken couldn't make it tonight. I'm not sure if he's gone camping or what it is, but he's not here, so we'll take over for him. One thing that I was going to say was that we are starting to work on a new program for our sessions, and it's going to take a little bit of time to put it together. So I was going to say this would be a good opportunity for people to make suggestions for what they'd like to see for presentations or topics of discussion. This would be a good time to make those suggestions now, and we can do that either email me or announce it here or announce it on the group's IO, whatever suggestions you may have. So please give us some thought about it and let us know. And we're also looking for more presenters, and you know, it's a great way to learn on a particular subject is to do a presentation on it. You got to do a little bit of research on it, learn about it, and then present it. So it's a good learning tool. So consider that as well. And I guess with that, we'll get started. Everybody's been here before, so nobody new. That's good. Well, not necessarily. It's nice to have new people, I guess. I was going to talk a little bit about the experimental methods in RF design. I'm not going to say really too much about it, really, other than you know, earlier on I was talking about the basic radio, basic electronic books and stuff like that. They're a good place to start, but really I find myself, I get into this one here that I use a lot for reference and ideas and what have you. And usually quite often I have to read it several times. You know, again, it's like any subject, you know, you kind of got to go 2 or 3 different resources to really get a handle on certain subjects. And we were talking about crystal stuff a little bit earlier, just before we got started, Michael, there. And this book I read a lot over and over for explanations when we were doing the SNA project. So that's a good one. And they did go out of print, but with the backlash from going out of print, I guess it worked. So the ARRL started to print it up again. And I'm not too sure how much it cost today, but it's certainly a worthwhile book, I believe. Okay, tonight got a couple of quick or a couple of presentations for tonight. Dave's got a good one going here, an introduction into why your impedance must match for maximum power transfer. So are you ready to take it away there, Dave?
Yeah, I think this talk is not going to, I think the people in this group are not going to get anything from this talk because they already understand this. So I was kind of aiming this more at the novices that we've got coming in. So
and none of them are here.
And none of them are here. So so I could go ahead and
go ahead, Dave, because you never know. We will get something out of it, and maybe we can ask you a tough question.
Sure.
I see you got rid of the old cat.
Wait for it. So, oh shit, this is ridiculous, man. I hate this. I hate this new version of PowerPoint. You know, I can't stand it. Because what happens, I've got multiple monitors. And so what it's doing, it's putting the, hang on, what I'm going to do is going to have to play around with my monitors here. What a pain in the ass.
Trouble with you high-tech guys, you know.
No, what PowerPoint, the new version of PowerPoint does, if you've got multiple monitors, it keeps PowerPoint in edit mode on one monitor and then puts the presentation on another monitor. So here you've got the presentation, and then on another monitor I've got it, but I had them switched around. So anyway, so what I want to do is give a non-mathematical explanation of why you need impedance matching. So, you know, as with all my presentations, just wanted to say, you know, I'm not an expert. So, you know, even the experts, what they say, you got to take with a grain of salt. So I'm in no way an expert here. I'm just explaining what little I know. So if you look at what impedance matching means, it means, you know, if you go to Wikipedia, it says, you know, it's such that you match the source and impedance, the source impedance and the output impedance connected to electrical circuit such that you maximize power transfer into the load, or you minimize signal reflection from the load. So what I want to do is, I'm not going to talk about signal reflection from the load. I was going to talk about just power transfer. Just look at a very simple case of the power transfer, and you can see why you need to have your impedance matching. So maximum power transfer, if you look at from a DC perspective, your source resistance is equal to your load resistance. In an AC circuit, your source impedance is equal to the conjugate load impedance at a frequency. So at a given frequency, the source impedance must be the conjugate of the load impedance. And if that happens, they're matched. So complex conjugate just means their resistance are equal, but their signs are opposite. So it's like a capacitive inductive load, and those are who are on the ball. And we'll say, okay, when the capacitive load equals the inductive load, what happens? Bueller, Bueller, Bueller. It's resonant. When you've got your capacitive inductance, when your capacitive reactance is equal to your inductive reactance, it's in resonance. You get a resonance. So that makes sense, because when you have, you know, them equal and opposite in sign, it means you've got a resonance happening. Now, in some cases, you could have a low source driving a high impedance, but that's more for delivering a higher voltage to the source. It's not power. So in the case like an op amp, if you look at the input impedance of an op amp, it's infinite. It's supposed to, it's very, very high, very, very high. The input impedance of an op amp is very, very high, very, very large. So therefore, you can have a small amount of load driving it. Whereas the output impedance of an op amp is very, very small. It's ohms. So which means it's meant to drive a high impedance source. And that's why you'll see in op amps, in the input, there'll be a resistor to ground, like a 50 ohm resistor to ground, and that forms the termination of the op amp. But I'm going off topic. So, you know, if we dumb it down, just in terms of this complex impedance. So if you look at this, if you've got a resistive load and you've got a complex load, you know, they're not matched. So you've got a resistive load driving a complex load, they're not matched, you know, an angry cat comes out. It's not happy because you've got a mismatch. So in this case, you would have to add, you would have to have in here a tuner, some kind of tuner that's going to add in the plus JX to cancel out the minus JX, and everything is happy. So in this case, if you put a matching network in your antenna tuner and you introduce a plus, you know, the conjugate of this here, okay, you introduce the conjugate of that, all of a sudden everything's match and angry cat goes away and you've got resonance, because this will resonate with that. All right, but that's all I kind of wanted to say about that. This can get very, very complex. No pun intended, because it's complex numbers. But what I wanted to focus on is I wanted to focus more so on the DC case. So this is just showing you, you know, resonance. If you've got an inductor and a capacitor and both are equal and opposite in magnitude, it's at resonance. So what I want to do is focus on maximum power. So we've got our little transceiver here. We've got an antenna. How do we maximize the power going to that antenna? So let's ignore the complex mumbo jumbo and let's just look at a purely DC case. Because if we look at a DC case, it becomes easier to understand. So I'm going to introduce a really, really simple 50 ohm radio. So I'm going to take this radio. Do you guys recognize that radio?
Yeah.
Right? Yeah, it's Hans Summers. Right?
Summers,
Yeah.
So I'm gonna take this radio and I'm gonna simplify this radio as simple as possible. And we're gonna have a voltage source and a source impedance. Now in this case, TH here, I copied and pasted this in. That's supposed to be the Thevenin equivalent resistance and Thevenin equivalent voltage, but ignore that. Just it's a voltage source and it's a resistor. And in this case, RTH is 50 ohms, so this red box is our radio. This becomes our radio. Very simple. Okay? Questions? Better not be. Angry cat will come out, right? So next, we're going to put an antenna. and the antenna is going to have a load RL. So we've got the source impedance RTH and load impedance RL, and any amateur knows that both of these have to be equal. In the case of radio, they're 50 ohms. But why do they have to be 50 ohms? Okay, why not 75 ohms? Why can't the antenna be 100 ohms? Or why can't the antenna be 10 ohms? And ignoring the SWR and reflection piece of it. Okay, so the dreaded math. So we have to do a little bit of math, just slight math, right, to figure out what's going on. Just a few simple integrals. No, it's really, really simple. Because if you take a look at this, okay, you know, you've got, in this simple circuit, you've got two resistors in serial, the same current flows through both, right? Whatever current flows through RTH flows through RL, I is the same going through all of them, each one, right? Okay. So next is the, so the current flowing through here, okay, is going to be the voltage divided by the total resistance. Does everyone get that? Really simple, right? Simple, simple stuff. The current flowing through here is going to be the voltage, VTH, divided by the total resistance. And you can see it here in this equation. I, the current I, is equal to VTH divided by RTH plus RL. Simple, right? Okay, anyone's brain melting so far? Okay, so the next thing you have to know, the power dissipated by any component here is I squared R. And it could be V squared over R. You just use Ohm's law. This stuff is basic amateur radio 101. Anyone who's passed their Canadian basic license should know this. If you haven't, some of us here have not passed their Canadian license, right? And so may not understand this, but it's really simple. So here, the power, the load into this is I squared R. So we take I and we substitute it in and we get this equation here. So the power in the load is equal to this equation. So what we want to do now is we want to go through and look at this and say, okay, what resistance do we need to put, if this is 50 ohms, what resistance do we need to put here to get the maximum power transfer, right? So this is perfect for using an Excel spreadsheet. So if I open up my little Excel spreadsheet here, hopefully it works. Where's my Excel? Well, I guess it didn't open Excel. Yeah, I'll just open it up manually. So here's the spreadsheet. Here's the equation we're using. So I've got here VTH, and I've just arbitrarily chose the number 200. I've just picked a number 200. I set RTH. Remember RTH here? I set that to 50 ohms. I set RL, and I'm going to change RL, and I'm going to look at the power dissipated in this resistor and the power dissipated in our load. And I'm going to take a look at that as a function of RL. And I plotted the information, and you can see very quickly from the plot, the maximum is about here, which is about 50 ohms. Magic. So you can see it just, without going through a mathematical proof, you could easily see the maximum power transfer into the maximum power into the load is 50 ohms. This plot is I'm plotting power here versus the resistance here, RL. So if you look, if RL is low, if RL is 0, then all of the power is being dissipated by the source resistance here. This is why you don't short your radio out, right? Because if you short your radio out, all the power into that radio has to be dissipated internal to the radio. And that's why you go and you fry things, right? So if we look at this and we come down and we continue down, we'll see here at around 50 ohms, our RL is 50 ohms, you'll see the power in the load is 200, which is the maximum. That's our maximum power there. So it's right around 49, 51 ohms. We get about 200 ohms, 200 watts. So you can see that only happens when the source and load impedances are equal. Does that make sense? Very simple example. You don't have to go through and solve integrals or equations. You just look at this simple example and you can see that's why. And you can also see why you could also drive your radio with a little bit lower resistance. You know, you don't have to have exactly 50 ohms. You could have 40 ohms, and you're still getting almost 200 watts coming out. So that's the whole thing about having an SWR that's a little bit higher. You're still getting lots of power being transferred if you've got a slightly high SWR. You don't have to have a 1-to-1 SWR. You could have like a 1-to-5 or 1.7 to 1, and you're still going to be getting close to the maximum amount of power being transmitted. Make sense?
Yeah, you always make sense, Dave.
Okay, and that was it. So that's the presentation. The other thing I was going to do, if I have time, or if you guys are inclined, I could go through this in LT Spice. So I could show you how to do this in LT Spice, and we can make the similar measurements in LT Spice. I don't know if you guys want me to go through and do that. Anyone here want to learn?
Yeah. Yeah, we got lots of time, Dave.
Yeah, go ahead, Dave.
Yeah.
Okay, so LT Spice. I'm not going to show you how to install it, how to, that kind of stuff. I'm just going to go through some of the basics. Once you start LT Spice, okay, there's a little thing here that says new schematic. So you have to create a schematic. Every time you use LT Spice, you have to create a schematic. So you create a schematic and see how it changed. All of a sudden, you've got a whole bunch of tools appearing here at the top. Can everyone see this okay? Right? So
yeah.
With LT Spice, there's a couple of things you always, most of the time you're going to do is you're going to have to add components. So this little button here is where you can add components, and there's some pretty standard components which you're always going to be using. They're here at the top: resistors, capacitors, inductors, diodes, which are typically you're going to be using those a lot. So they've got them shortcuts here. But any other component, you hit this component button, and it's going to allow you to add components. And they've got all kinds of components here. So the one most of the time you're going to be using is your voltage source. You're always going to be putting a voltage source in. Okay? And the other thing which you always have to put in is you have to put a ground. Okay? If you don't put a ground in, Angry Cat comes out and gets pissed off. You can put one ground in for everything, or you could put multiple grounds in. I'm going to put multiple grounds in here. Okay? but you could use 1 ground. It doesn't matter. So I'm going to choose a resistor, and I'm going to put a resistor here. So you click on the resistor, you move it to where you want it, and it's a grid. It snaps to a grid. So you put your resistor, and then we had another resistor. Now notice the resistor is oriented this way. If I want it to be oriented horizontally, you just press Control R, and it rotates. Control R rotates the component. So you press Control R, you rotate the components, and there you've got your components. Now to connect up your components, you go to this little pencil, and it's a wire. So here you draw wires. So you just go to these little boxes, you click on one, move the mouse to the other one, click on the other one, and it places a wire. Very simple. And if you want to do a bend, you would click, come up to where you want the wire to bend, click again, and the wire bends.
Dave, for a little shortcut, you can draw right through the component.
Yeah. Yeah. You could also, if you want to, you could take a component and you could do this. And you can just place it like that, and it draws it. It puts it in. If you want to remove a component, use the cut, and it cuts it out. So let's connect back up this. So there. So what we have to do, let's add a voltage here. What do we use for a voltage? It was 200, right? 200 volts. So let's reset. So if you right click on the component, it comes up and it asks you what the voltage you want. And it's also, it can embed a series resistance in here as well. I chose to put it external. So remember, this is my radio, right? So if you want, you could put a series resistance in, but you don't have to. Advanced is if you're going to be doing AC analysis. But for the time being, we're just doing DC here. So same thing with the resistor. If you want to change the value, you right click and you just put in your value. So I'm going to say it's 50 here. And this one, let's put this at say 50 for the time being. Okay, so again, you right click, it comes up resistance, you put 50 in, and you say okay. If you want, you could say 50R as the unit. You could say 50U for micro. You could say 50M. You could say meg for mega. You could use 50M for milli, or you could say 50R for ohms. So you could do anything like that you want. Very simple. Okay, so we get it. We got our circuit defined. So now we have to run the simulation. It's got a little guy running here. The first time you run this, it comes up with a dialog. Okay, most people are going to click the transient analysis, but you guys should also look at the DC operating point. This is kind of cool here, because if you click the DC operating point, okay, we could run this, and here it comes up and it tells us what our DC operating point. So it comes up and it tells us what all the voltages are. So the voltage at VN1 is 200. The voltage at VN2 is 100. The current at R2 is 2, and blah, 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 and so forth. Okay? Now this is kind of cool, because if you just go to the line, it'll tell you the voltage down at the bottom. Look, down here at the bottom of the screen, you'll see the voltage. See, it says there, it tells you the node. It's node N001, and the voltage is 200 volts. Here, the node is N002, and the voltage is 100, which makes sense because it's 50-50. It's a voltage divider, right? Okay? So the other cool thing is if you click on a node, see it pops up this little window here, and if you click on it, it displays the voltage at that node for you. So now if I go here and I change this, and let's just say I make this 1 ohm, and I run this, it gives me my voltages. I click this, it updates it, and it said with 1 ohm there, your voltage is 3.9 volts.
Dave, how did you do that? Was that a left? I don't recall seeing that before. How did you do that?
This is the DC operating point.
Oh, I see. Okay,
That's what I said, because almost everyone here goes and does transient analysis. If you go way over here, you do DC operating point. See the what's it called? What's this called again? Not the macro. The what's it called? It's up here. The directive. The SPICE directive.op is giving you the operating point. And so you could drop these markers everywhere you want, right? Okay, so this is how for DC operating point for voltages and currents, you could use that. Now, if we want to view currents, we have to go, if we want to view power, we have to go back and we don't have a choice. We have to use transient analysis. Okay, because only transient analysis is going to give you power. So the stop time, because we have no capacitors to charge, nothing to settle, you know, normally you would choose a stop time to allow the circuit to settle. So, you know, once it starts doing its calculations, you want to run it long enough so all the calculations will do what's called, they'll all converge, they'll all stabilize. So let's use like 10 milliseconds, for example. So now you'll see it gives a SPICE directive here of transient 10 milliseconds. This .op disappears, right? It's now commented out. So this is the directive that takes effect. So let's just go and let's just delete these things here. So let's go and run this now. Now it pops a graph window up. Okay, so we can click on the part and it tells us the current. So in this case, we have 3.92 amps flowing through the circuit. We got a little probe, and if we touch the wire there, it'll tell us the voltage. So here's the voltage here. So the voltage is 3.92 volts. Right? So what I want to show you guys now, though, is how to measure power. Do you guys know how to measure power?
Do a math equation?
Nope. It's trivial here. So all you do, you run your simulation, you hold down the Alt key, and your icon, once you hover over a part, it becomes a thermometer. And it's saying measure power. So you see, normally if I don't press the Alt key, you get a little, like a current sensor picture, and you press the Alt key, it turns, see I'm pressing the Alt key there, it turns into a thermometer. So here, if we go and we look here, and we do the thermometer here, it's coming back, and if we measure it, it's coming out 769 or so watts. 769 watts is being dissipated through the 1 ohm resistor. Or sorry, through the 50 ohm resistor. If we look at what's being dissipated through the 1 ohm resistor, again, Alt, and here's for R1, it's the blue trace. You see it's almost 0 watts because it's almost a short, right? So all the power is being dissipated here. So we can go and do this. So here you're seeing all the power, you're getting all the power being dissipated here and very little power being dissipated here. So let's make this now, let's make this 100 ohms. Okay, and let's run this. So in this case, the power being dissipated in a 100 ohm resistor is 90 watts, and the power being dissipated in the source resistor is almost 180 watts. So you see, we've got quite a bit of power, unequal power being dissipated in the resistors. So if we make this 50 ohms, where it's matched, and we run this, bingo, both are equal. Both are 200 watts. Can you see that? Both lines, you're seeing the blue, but they're both the same. If you click on this, if you click on it, it brings up a cursor, and you can move the cursor, and it's giving you the measurement here. So you can see it's 200 watts. Regardless of time, if I click on the blue trace, here you see it's also giving you 200 watts. So the power is equal. QED, there you go. Very, very simple introduction into LT Spice, how to use LT Spice. So what I'll do in all my other talks, I'll be doing, whatever talk I do, I'll always try and bring in LT Spice and run a simulation in LT Spice to show you how it works. This is a very, very simple case. Very, very simple. Any questions so far?
Just a comment. If I'm looking at a transistor circuit and I simulated an LT Spice or an oscillator or whatever, I always check the operating point, the DC operating point, make sure I got the right resistor values and whatnot.
Right, right. And that simulation, a lot of people don't use that. And I've done, you could do a DC sweep. I don't use that much. I primarily use AC analysis or transient analysis. Have you guys ever done the fast Fourier transform in this?
Rarely, but the odd time.
Let me see if I got a circuit and I can show you how to. Okay, I think this is. This here is for the power amp, Peter, in the Dual Link 612. Okay, so if I was to go and run this, I don't know how long it's going to take to run. Well, it may take a while. It's taking a little bit of time here because it's got so many components that it takes 20 or 30 seconds to run. So it's 60%, 70%, 80%, 90%. There we go, 100%. So if I was to click here and I look at my output, I get a nice wave, and I can look at the power, Alt, right, get my thermometer, and I can look at my power. Now it's giving me the, let me delete this trace. And let me resize this. So there, see, now it's giving me what the instantaneous power is. So what I want to get is I want to get the RMS power being delivered here. So if I click on this, but I use Control, I hold down the Control key and I click here, it comes up and it gives me the average, the integral. So in this, I think I have to select, do I have to select a portion of it? Because it's not giving me the RMS value. It's giving me the average value, which is saying it's 5 watts average coming out. So the average is about there. But I thought this would give me the RMS. I guess not. So now for Fourier, so let's just look at it here. So this is going to be gnarly. See, it's gnarly because it hasn't gone through the low pass filter. It's the waveform is all gnarly. So if I was to right click on this now, and I go down here to view, and I can click FFT, and it comes up and it'll say for node VN006, which is what I've got plotted. Do the FFT, and here's my FFT, and you'll see there's tons of garbage. So if I click here, you'll see that there's a fundamental at 7 megahertz. Here's another at 14 megahertz, and this will probably be 21 megahertz, and so forth. So I've got all the harmonics appearing, and if you look at the distance, but how much this harmonic's down, it's not down enough, so therefore I need a low-pass filter. So if I go in now and I look at the waveform at the output of the low-pass filter, looks a little cleaner. So let's do an FFT on that. So there's my fundamental, and there's my harmonics. They're down quite a bit, and I can measure how far down they are. So there it's difference down 44%, 44 dB down. So that filter has knocked down the biggest harmonic down 44 dB. Cool?
Cool.
So that's how you would do an FFT in LT Spice. I use this all the time when I'm designing this to make sure that, you know, how clean my signal is. So that's it. I've gone well over the time here. I've been talking for what, about half an hour?
Well, that's okay, Dave.
Any questions?
Hi, Dave. Do you pay for the license of LT Spice, or is it free now?
LT Spice is free.
LT Spice is free. Okay.
Sorry, it's
The current version is LT Spice 7, which is virtually the same as LT Spice 4, which
yeah, the version of LT Spice I'm using an older version. What version is this? This is 4.2.3.
LT Spice, you're using there's a version LT Spice 7, which is what you get if you download it now. It's
Yeah.
LT
Yeah, I use this version. I use an older version because I've got a lot of libraries and a lot of circuits built. Like I have a
Cherry, can you mute your mic?
yeah, and I've got a like a you could do sub circuits, and you could put things together into a group. And I've got a whole bunch of things like that done, and those things will break in the newer version of LT Spice. So I'm just lazy.
On the topic of newer version of Spice, on the LT Spice IO group back a little while ago, the author of LT Spice, Mike, I can't remember his last name, Engelhardt or something like that. Anyway, he's left LT or analog devices, and he's actually working on a new version of Spice. He's rewriting it. He says he now knows what he did wrong, and he's rewriting the whole thing, and he's going to have it open source. So he said he'll announce it when he's ready on the LT Spice Groups IO. So we'll see what happens coming up down the road on that one. Okay, well, thanks, Dave, for that. That was very interesting. Thank you. Let me see here.
One question, if I might.
Yeah, go ahead.
Dave, the Alt and Control keys, is there anywhere you can find out what you can do with those shortcuts?
Actually, I was actually muted and I'm talking here. Yeah, I went searching around for that to get RMS values because I figured, you know, I use Google. right? And so I'll go Google LT Spice RMS value, and I'll find someone's blog who they talk about how to measure it. The other thing too is linear technology. I think who bought linear? Someone bought them, right?
Analog devices.
Analog devices. So if you go to their website on LT Spice, they've got a ton of videos and they explain a lot of this stuff. I found that out after the fact of using Google to search and find these things out. So I did it the old school way. I just used Google out of necessity. It's like, okay, how do I measure power? How do I measure impedance, input and output impedance, and stuff like that, right? So I use Google, and I go through blogs and videos, and I eventually figure it out.
What about the control and alt keys you use? Is there a place you can find a list of what you can do with the various keys?
Yeah, like I said, I just Google and I came across it. If you find a explanation within, the LT, it might even be in the help file.
I think it is, Dave.
No.
It's been a while since I've been in there, but I think the shortcuts are in there.
Yeah, if it's there, it might be there. I find those help files useless.
I'll have a look. Thanks.
Any other questions? Okay. Thank you, Dave. I will just do a quick little presentation here on the LTC 6900 just to finish it off. What I did. Whoops.
I thought that was going to be me.
What's that? Oh, yeah, right. Okay, let me just get this thing fired up. Share screen, applications. I'm assuming we can see that. We can see that?
Yep, looks good.
Okay. Okay, my goal here in part two, like last month, I was just showing how poor the drifting was, etc. When we were talking back then on the 7 megahertz area of frequencies. So this time I wanted just to really take a look at what was going on down at the kilohertz range. So that's what I've done here. Again, just a reminder of the circuit. And what we'll be talking about when I talk about different is the resistor here, and then the divide pin here, whether it's going to ground, open, or plus 5 volts. So what I did here was I just did R1. I set at 28K, and the divide pin was at ground, and that generated a signal at 7 megahertz. And there it is. There. I didn't bother this time looking at the drift and whatnot. Now, if you're looking closely, you might see some differences in the frequencies between what was on the scope and what's on the spectrum analyzer, and that's because some of my shots I was taking quite a bit later than the other shot, and of course things settle down, warm up, drift, who knows. And again, same thing, 28K divide pin at ground, and there's the harmonics that generated in the 7 megahertz fundamental, which is, there's the fundamental there. And then the first harmonic is here down at minus 26 dBm. Okay. And then of course the third harmonic is much higher. So then I went down and took a look, and I did the divide pin open, kept the resistor at 28K. And now I got the frequency down at 718 kilohertz. And you still have those little blips here, spurs here on the side. And let's see what I got here. Yeah, so that's what that one looks like. And the drift here, by the way, is starting to is nowhere near what it was up in the megahertz range. I didn't measure this one. Oh, well, in this one here, I think, did I measure this one? No, I didn't measure this one, but it is much more, it is less than the when you're up in the megahertz area. And then this is just the harmonics that were generated with the divide pin on the open. Putting the +5 volts on the divide pin produced 71 kilohertz, 71.5 kilohertz. And when I connected the spectrum analyzer to it, I did get a little bit of distortion coming off of the that I picked up on the scope, but the signal's much cleaner, as you can see. And there was some drifting, but very, very small. And it was, as a matter of fact, it was the point where it was pretty hard to measure, so I didn't bother. And but again, down in the lower kilohertz area, things are starting to settle down a little bit more. So then I got curious about, well, if the drifting and everything is settling down, how about if I, oh, here's the harmonics, just to keep things the same. So what I did then was I got curious as to, okay, well, let's hook it up to our direct conversion receiver.
Hey, Pete, can you just go back to that prior slide?
Yep. That one?
Are you measuring it from 0 hertz? Like, is that, what's that first peak there?
Oh, the first peak will be 70.667 kilohertz.
So not one, the one before one, right at the axis.
I don't recall exactly what it was set at.
Oh, is that just DC? Is that you're measuring it from?
I'm measuring the output. That's the harmonics on the output of that chip, and I forget exactly where the lower range was. And maybe it's at 0. I can't remember, Dave. Why? You're referring to the span, correct? Did I lose somebody? You guys still hear me?
Yeah, I can hear you.
Oh,
Yeah,
okay.
I think Dave's just frozen.
Oh, Dave froze. Okay. All right, well, I'll move on then. I'm not sure. I guess I don't know if I answered Dave's question or not, but he'll come back. And okay, so I got curious as to the audio. So I connected this up to our DCR board, the prototype, and I mixed it with another signal generator I had, and you can see on the spectrum analyzer there, you can see the audio signal. So that signal, well, the frequency at the marker 1 is 1.8 kilohertz, and then the other marker is 2.06 kilohertz. And you can kind of see it's pretty gnarly, as Dave's favorite term. And listening to it, well, the audio is as bad as what it looks like. It was very, very, very distorted. But I could control it. As I said, going up and down with the pot, the frequency change was very, very controlled. It was quite good. The drift was about like there, about 160 hertz. So that was interesting. A little experiment to this. So I was glad I did connect it up to the DCR just to see what it was like. But again, the audio was very, very poor, and you can see that on the display there from the spectrum analyzer. Okay, that's all I got for that. Let me just. Okay, I think we're back to normal here. Dave, we still lost. Okay, any questions? Oh, and that's, by the way, that'll be it for me in the 6900, so everybody can breathe a little bit of a relax there. You back, Dave?
Yeah, I don't know what's going on. I think the wife and kid are using the internet. Can you hear me okay?
Yep. Yep. Okay.
So, Peter, with the DCR project, how far along are we with you know, how is that getting close to fruition?
Well, a little bit later down the list here, I'll ask Frank that very question.
Yep.
Okay. Kevin, are you able to speak? If you unmute your mic, Kevin. Okay, well, maybe Eric, maybe we'll go over to, I know you had something you wanted to show us tonight?
Maybe we're getting too aggressive with our muting of the mics. Everybody keeps them muted.
Well, I know Kevin is coming up from up north, and I think he's using a phone or something there to come in, so he wouldn't have the.
Hello. Hello.
Looks like he's there.
Yes. Okay, we can hear you now, Kevin. You all right?
Sorry. Oh,
Yeah,
okay.
ahead,
Yeah. Sorry. Yeah. It's the mobile phone experience at the cottage. So it's, you know how you touch everything and then the screen disappears and it comes back, and anyway. So anyway, I'm finally here now. I have an excuse for being late, but it's not a good one, so we'll just leave it at that.
Well, if you told me you caught a nice big fish, then I'd buy it. But if it's not that, then forget it. We don't want to hear it.
No, sorry, it had nothing to do with fish.
Okay.
Anyway, so okay, I volunteered to talk about the Hack RF. So I took a few pictures of it. So I'm going to try and figure out how to share my screen with pictures rather than trying to do live video feed. And anyway, so this thing was inspired by I heard, Peter, you and the guys in Kingston were always talking about these things, and I was bored in the middle of a pandemic, so I ordered one off AliExpress. But this one has some extra features other than the bare board. So let me see if I can figure out how to share a screen here.
Okay, well, while you're doing that,
Hang on.
while you're doing that, I'll just up here in Kingston, guys, we have one guy who's really good with GNU radio, and he started to do a couple of online Jitsi sessions with a few of us, going through, you know, simple FM receivers to transceivers to well, all kinds of things, getting a little bit more complex each time. So that was a pretty good little session that we were running through on the GNU radio stuff. Unfortunately, he's been transferred to Ottawa. Although I guess you can still do a Jitsi session no matter where you are, as we're proving now.
So, okay. So yeah, anyway, the, you know, cause it's, you know, an SDR, and I had bought that Lime SDR thinking that would be like, you know, the answer to everything, but anyway, it's not. Because it had a lot of capabilities, but I don't think the quality control was what it really should have been, as it was, you know, leaving their factories. Because there was always issues with the firmware being reset, or you're having to reset the firmware. So anyway, I can't seem to be able to share the screen, so I'm just going to try video.
Well, for what it's worth, your video is not. It's showing.
Sorry?
Your video showing disabled.
Yeah, no, but I'm just, so I'm going to put the video on, except why is it not allowing me to do that? See, when you have a phone and you click on it, it should allow you to manage the video, but it doesn't. So hang on here. Bear with me, guys. It's the mobile experience.
Oh.
Actress and camera, share. Oh, look at that. Oh, okay, I got some. All right, sorry. You're looking at my kitchen table. So
I thought it was a marijuana.
Yeah. Well, I guess, yeah, that's could interpret that or interpret it that way. Anyway, can everybody see that? That's the Hack RF. But the difference is it comes in a little enclosure, and it's got, you know, it's got like a little encoder here that you can move stuff around, and it's got a 4-way kind of joystick device. Anyway, so this is the Hack RF, but it's got an extra processor, I believe. And although I'm not sure, I was doing some research on it, and so I couldn't get a clear answer. But anyway, it's even backwards. You want to go left? You got to go right. Okay. But the interesting thing is, so this thing has a bunch of programs and software built into it that you can run as a portable device. And that's what kind of got me interested in it, because it's like, it's not just a hack RF that you can, plug in GNU radio and do neat stuff, but it's got all kinds of sort of canned functions. So if you want to listen to ADSB with it, and there's a place to put an antenna on the front, you can listen to ADSB. It will sit there and log aircraft going by, and it will decode it. And I thought, well, that was kind of cool. And then there's, I got to get up there. There's ACARs, you can do the boat thing, audio functions. So you've got, in this case, it's set at, special, hang on. So you can do AM, narrowband FM, wideband FM, and special. I'm not sure what that is, but anyway, I'm still learning about it. So you can do all these neat things. You can listen to basically any frequency and any common modulation between like 1 megahertz and I think it's 6 gigahertz. Is it, Peter?
I think so. I can't remember. Yeah, I can't remember. That's a really cool add-on. That I didn't see that option. And some of it's not. Well, it's not really an option. You got to kind of. Sorry, got to try to hold on here. You gotta look at it, look around for it, and when I saw this, I thought, well, that's really cool. And the other part is it's even got like this neat transmitter function. You can actually, it's got like a jammer, which strictly speaking is illegal, but I tried it on our bands, and I have another handheld sort of cheap spectrum analyzer, like an RF meter with a FFT on it, and yeah, it works just fine. It you set a, like, say 410 to 420 megahertz, and it randomly transmits carriers between that frequency. So I mean, legally speaking, it's not. Burger pager. Apparently, some restaurants use a certain kind of pager. You can trigger the pagers with this thing, and it's like, okay, not sure why you'd want to do that, but anyway, you can. On-off keying. You can set symbols, and it will simulate an on-off keyer. So things like cheap wireless doorbells, that kind of stuff, you can simulate them. So there's a lot of cool things here. Slow scan TV. Okay, it doesn't have any bitmaps, but it will sit there and transmit a signal on our bands to transmit a picture using slow scan TV. Is this is this thing? So I guess what you're doing then is you're downloading new firmware into the or program, or what is it you're doing with the hack RF?
Yeah, somebody wrote firmware. Yes, somebody wrote some firmware that lets. Sorry, I'm trying to keep it on. Everything's backwards. Somebody wrote some firmware that does all this stuff, and there's a couple of GitHub sites that let you download it and do something with it. So if you the other really interesting thing is this capture function. And what you can do, and I don't, for some reason, it's not liking my SD card. I think it's not formatted correctly. It's not a FAT32 format. But you can go down here and you can see the waterfall going. But if somebody was to like press a car key fob, it'll record the exact digital waveform. And if you're not within range of the car, you can record it. Then you can walk up to the car and you can unlock it. And that's what these got. That's what made this so very, very popular with the, some certain aspects of the population that like to go out and do this kind of stuff. So anyway, it's like, and you can go buy this on AliExpress for, sorry, my screensaver keeps going off here. You can go get it on AliExpress for like 170 bucks Canadian and wait 3 months in the pandemic. So, but anyway, it's quite the RF device, as I'm finding out. So anyway, if you want to play with if you just want to mess around and play with stuff in RF, it's pretty cool. Even it's got a scanner, You know, it'll look for certain aspects. It's got a spectrum analyzer that'll do, I think, 18 megahertz at a time. So anyway, it extends the capabilities of the Hack RF, and when you're bored, you can just make it into a regular Hack RF and plug it into your computer and download GNU Radio, and away you go.
So you're actually, okay, so that's what I was going to ask you then, Kevin. So you're not actually replacing the firmware that's in the Hack RF. This is just an add-on on top of it.
Yeah, exactly.
Okay, so you
normally when you plug, yeah,
so you can actually just go ahead and plug in GNU Radio if you want and do something different then, easily.
Yes, that's correct. Yes, yeah, you can still do that. And sorry, I just dropped the video because I'm trying to conserve bandwidth here.
That's a really
anyway. So yeah, and you can walk around with it, right? I mean, it's a scanner. I was sitting here this morning playing with it. And it's got a TPMS monitor, a tire pressure system monitor. So on certain kinds of vehicles, it will actually listen for that and decode it. As I texted you, Peter, it will sit there and it will grab the data from the tire pressure monitors, and it will display the tire pressure and the tire temperature, which at 6 o'clock this morning was not very interesting, but it was just cool that you could do it.
Probably not interesting at 6 o'clock at night either.
Probably not.
Oh, that's really cool, Kevin. I have to take a look at that, or when we get all together, whenever that may be. Is there any other questions for Kevin on?
So what is the upper frequency limit of that?
I think it's 5.8 gigahertz. So it covers the regular 2.4 gig Wi-Fi and 5.8 gig Wi-Fi as well, I believe.
Okay, so from the lower limit to the upper limit, you can simply put on a screen and scan it to see if there are any signals altogether from the upper to the lower limit.
Well, I don't know that it'll go that wide, and if it did, your resolution would be pretty low. So I think the maximum is like 18 megahertz at a time. I believe from this firmware, but I may be wrong because I haven't explored it all. This thing came as I was closing the doors on my car and getting ready to leave for the cottage, and the Canada Post drives up and says, "Are you Kevin?" I go, "Yeah." "Oh, that's my package I ordered 3 months ago." Great. So anyway, it was literally on the slow boat from China.
Cool.
But yeah, so 1 megahertz to 6 gigahertz, give or take, and overall, but it can't do that as like a single scan.
No, that's a bit much. Any other questions?
Yeah, and just was wondering, like, which model year it is. Like, I was just doing a quick search and I found 2019, or there is one more, or?
Yeah, the firmware is like some 2019 revision. I haven't looked at it to see if there's anything more recent.
Okay. Thank you, Kevin.
There's a software package that I used with my Hack RF. I can't remember what it's called. All my stuff is put away, but it's basically you run this software on your PC. You connect your Hack RF, and it picks it up. It loads it, and it just starts displaying what the Hack RF receives, and you could go in and program it. And for the life of me, I can't remember the name of the package, but it's kind of like, the software we use with Little Pup. Remember?
Oh, okay.
Yeah, SDR radio or something like that.
Okay.
Or Quisk. I don't know. Giuliano uses that Quisk software, but it's kind of something like that. But it's a package, and it's very difficult to get those packages to work with Hack RF because you got to get the right driver. But this package, it just knows about it. You select it, and it works. And it was really, I tell you, it's a cat's meow. It was really, really slick.
Well, hurry up and start digging through those boxes, and so you can let us know.
Yeah, I can't remember what it was, but I used that for a while, and that I found to be really, really good. A really good package.
Yeah, I know I was messing around with GNU Radio for a little while, especially with a couple of those GUI different GUI things that they have in there, which is kind of cool, you know, with the waterfalls and the different types, et cetera, et cetera.
But GNU's a pain in the butt to go and set up and use, right?
Well, yes. I mean, I can make things work and do things, and I don't understand what I'm doing. It'd be great to show you guys what I've done, but you would ask a question, and then I wouldn't know how to answer it. I just know how it works. So I'm just hacking into it, not without understanding. So anyway, okay, good. Eric, are you ready?
Sure. Yeah, actually, I just realized my video's been off. Let's get that.
Well, Eric, I think Eric is going to show us something that should put Dave to shame, because I never thought I would have ever seen this. Dave's in boxes, and Eric is coming out of the box, out of the closet, out of the box. So that's quite a switch. What's going on here?
All right, there you go. Got my video back. Wow, look at that. Nice empty office. Okay, yeah, not a whole lot to share here. I do have a question or two for you guys at the end, but I'm going to start sharing my screen now, which is this. All right, so there you go. I think there's only maybe one or two of you that are present on this call that saw the state of my, furnished room / storage area. That also doubles as a couple workbenches. But anyway, it is slowly getting whipped into shape. As you can see, lots of empty storage shelves to organize my stuff on. I know, pretty mundane things here, but I am making progress, so that's good. Dave and Hassan saw the state of affairs a little while ago on field day, and can maybe vouch for the improvement there. But anyway, so yeah, I've got a little workbench space eked out. I've got my scope and a couple power supplies there that I'm just kind of putting into place. So
what's that above the your scope there, Eric?
Oh, that's a actually it's a SAD light, seasonal affective disorder light. Not that I suffer from that, but it makes for a very nice working light, and makes me less grumpy. So I usually switch it on the mornings when I'm going for a hike with Dave or whatever, and or afterwards, and puts me back in the right mood. So anyway, yes, no, nothing scientific there other than providing the whatever 10,000 lumens at the right frequency to make my days brighter. But yeah, it's amazing some of the things that I don't know if you can see is my pointer showing?
Yes, it is.
It is? Okay. Yeah, look, I found things that I didn't even know I had. When you start organizing and unpacking, several years worth of trips to Dayton, etc. There's a nice, I think, 8 to 10 amp hour Bioenno lithium iron phosphate battery that I, like I said, didn't even know I had. So, all kinds of wonderful things come out of the woodwork. So there's my other sort of repair bench kind of place. But anyway, whatever, enough of that. Nothing too exciting, but full of, I guess, opportunities, places to work on some of these things. That's my operating open air shack that I was mentioning to you, I think, earlier, Peter. The obligatory bug net suspended over there. So actually, I plan to probably go on later tonight and do a little bit of either receiving. There's a shortwave show that I do tune in, and at the same time maybe see if NeoWise is up in the sky for me. Maybe the gods will be smiling on me and reveal it to me. I've been looking for the last 6 or 7 mornings, early mornings, and now into the evenings, but it has been eluding me as of yet. But anyway, so
I think the skies are a little bit clearer tonight, I think.
Yeah, it's always just been a little thin band of clouds right where I want to look, as Murphy would have it. But so anyway, yeah, I got my 817 out there, and I'm finding all the little bits and bobs. My antenna tuner that I didn't have on field day is there, that I've been playing with and works well for tuning the 817 that has no tuner built into it. So getting all that stuff up and running together, which is kind of nice. So also, I think Hassan's on the call, but he graciously offered to give me a SWR meter for a nominal fee. He said he had several of them, but guess what? As I was opening up boxes, what did I find but one of these? So, you know, probably a, I don't know, 1960s era SWR meter. But my question for you guys, and again, this is not strictly speaking homebrew related, but that's the front face of the unit. So everybody can see that, I presume, right? Pretty straightforward, just a tuning kind of knob there, adjustment knob. But if I understand correctly, if I'm using this, I put it in the forward, transmit, and then I want to put the power to 100. Is that right? When I'm keyed down?
Yeah, that's correct. That's, you put it in forward, you key down, and
adjust the knob to
adjust the knob until it goes to set.
Set.
And then you put it reverse, key up, and it'll give you the SWR on the top scale.
Up here, right? What is this scale for? Any idea?
That's field strength. That's field strength.
Okay, because yeah, there is a jack for an antenna on the top of the unit that you can plug in. So, which didn't come with my unit, unfortunately. But okay, gotcha.
That's, I remember these things from my old CB days. We had these things. That's how we used to measure SWR.
Yeah, well, I think I mean it's good through 2 meters, as it says. You just leave the thing, you know, in line while you're working and see how it compares to the reported SWR on the radios. So anyway, yeah. So there you go. Nowhere near as technical as what you guys were just discussing, but that's where I'm at right now. So not too much else to report, but as I unpack, man, do I have a lot of kits to build, though. Holy cow! So,
well, we all know that. We've seen over the years what you've been buying and just boxing up.
So yeah. So whatever doesn't get built by Field Day North 2021 gets sold.
Say that again.
This is being recorded, isn't it?
Yeah. Say that again. What's being sold?
What's being sold? Eggs. Selling lots of chicken eggs.
Okay, maybe we'll have to maybe we're gonna have to do a little get together towards the end of the summer up at your neck of the woods or something like that.
Yeah, no, absolutely. All right. Anyway, that's it for me. Thank you.
Do a buildathon. Do a buildathon. Everyone comes over and builds one of your kits, all in one day.
Well, only if I get to take it home, but
only if it works at the end of the day.
All right. Thanks, Eric.
Okay.
Frank, any chance you got an update with the DCR project?
Yeah. Excuse me. We pretty well scrapped the idea of a very small VFO being digital. It works very well with the signal generator. And if we can come up with a design that is small enough, there's lots of designs out there, but they're just as complex as the entire DC receiver. So there's really no point in that. The project itself is very much alive. The status of it, of course, is we've done the proof of concept build, and it works. We have our first prototype, and it needs a second prototype, as usual. Things are held up because of the COVID-19 situation. The second prototype will be put together as soon as the Humber College will go back, and Kelly has access to the equipment he's been using. The only change in the design that I've been looking at is maybe a double tuned front end instead of the single tune one that we've been using. They have one in Spratt that the GQRP Club put together for their sudden receiver, and it will fit in just it's plug and play anyway. The band filter in the front is pluggable, so that we can use this on many bands, as is the VFO. So that's what we're looking there. I'm still thinking about offering a plan for the case that can be made on a 3D printer, but once again, that's waiting for the libraries to open up so we can get in there, and we have a design for it, but we have to build one. So we're still in the prototype stage. It's still a very ongoing project, and when things clear up, and of course now we couldn't hold a build-a-thon if we wanted to. The church is pretty well closed down, with the exception of I do a video presentation there each Sunday, and there's only about 4 of us involved. So the services are going on, but as far as opening the room for other things to go on, no, that won't be possible. While I'm on here, I finally started digging out my ham radio operating desk, and I found that I needed some cables to connect to the watt meter that I have, the QRP watt meter. And so instead of finding adapters and cables and all the rest of it, I finally did a project that I wanted to do for a long time. It was to take the PL 259 connectors, actually it's ISO 239 females, out of it and convert it to BNC. So all my equipment now is a BNC, and I finally got it on the air and found out that just like everyone's saying, the bands are completely dead. So the only other thing I did was can come up here and move the modem from the upstairs to downstairs and connect my computer directly rather than Wi-Fi. So I hope you see a difference in the signal there. This is the first time I've used it, but I'm still not happy with Bell speed. I phoned them, and they said, oh yes, they saw the problem. It's at their end. And then I got a recorded message that they fixed it. However, I still don't get the speed I expect to get. So that brings us pretty well everything up to date at the 3FAO.
Okay, Frank, thanks. Bands are dead. Maybe you should switch to dead. Where are you trying, CW?
Yes.
Yeah. Okay. Yeah.
I want to just add there. I've been doing a little bit of operating lately. Sorry, I didn't raise my hand there, but I've actually heard a lot of just about everything: sideband, CW, digital. Whenever I go on, I'm hearing a lot on 40, 20. A decent amount of activity. It seems every few megahertz there's people chatting away and making contacts. So
yeah, I would keep going at it, Frank, because the guys reporting here in Kingston, they seem to be finding stuff. Even on 15 meters, one of the guys was reporting that he was having QSO on 15. When was the last time we talked on 15? But and then the other night, although I was playing around with JSA Call the other night and had a couple of QSOs there, and that was pretty good. Garrick.
No, that was just practice.
Oh, I'll practice you. I'll sick Dave's cat on you. Okay. All right. Anybody got any questions, suggestions, ideas, whatever? now's the time.
Hey, it's Brian here.
Yeah, Brian.
Yeah, I just responding to Frank. I guess you hear what you hear, but I was just doing the statistics for my log for last month, and between the two straight key sprints I did for the weekend and the 2-hour one, and then the casual QSOs, it was about 55 QSOs total. So it's just a question of hanging around. I mean, I don't even bother past about 10 o'clock in the morning until moving around 4 o'clock or 5 o'clock, because 20 is a different kind of thing and a different kind of operation. But they're out there. You just sort of have to hang around. But of course, any kind of contest will bring them forward. So I was listening on Thursday when there was nothing going on, really too much. And then when I turned it on Saturday morning, there was signals galore. So I don't know. It's just a time of wanting one to be there and when you can be there.
I wasn't counting the weekends. Yeah, it's pretty busy on the weekends.
Okay. The DCR project, Frank. So we're just gonna. I got a little bit confused with what you're saying. But we're gonna go for the. We're just gonna go with the to hook up a signal generator to it for the VFO.
Well, there'll be a built-in VFO with it, so you'll have that, but it's LC type circuit. So.
All right, so we'll go back to the original and then have the fittings there for allowed to
That's right, just a plug-in for the signal generator.
Okay, and then now you're considering about doing something about the front end for filtering.
Yes.
Okay. All right. Well, that's good. Have you given any thought, Frank, to maybe a virtual build-a-thon?
Not in detail. Every time I think about it, I come up with a whole bunch of problems that need to work out. So I just put it out of my mind, but it could be a possibility.
Yeah, I don't see this going away anytime soon.
Yeah.
So, I mean, if you wanted to do something in the fall, I don't know.
We might be able to gear towards it. I've already started ordering parts, so I've got quite a few of the parts in stock. Mm-hmm. But the big holdup is going to be the printed circuit board itself. And once we get the final design, it's a matter of getting it manufactured.
Okay. Actually, speaking of virtual build-a-thons, Eric, did Rex ever do his yet?
No, I mean, he's just coming off of LobsterCon, which finished this past Sunday. So no news, nothing to report on that front. But I'll start pestering him again to see what his ETA is on that. I think he was getting pretty close to final design, though. So
okay. I thought you and Dave already had the kits and are raring to go.
No, not yet. But anybody who's interested in participating, I'm going to be offering to have him ship all the kits to me from the States to be, the single point of entry. So, I'll send a message posted on the group's IO for anyone interested in participating in that. I think, I don't know what the price is going to be for it. I'm guessing something around the $50 mark, maybe less, but Rex always prices things, so he usually loses a few dollars, right? So, yeah. Anyway,
you're going to drive mine to Kingston, right?
Absolutely, door-to-door delivery. Yeah.
So okay.
For the right beverage.
I'll make sure to put on another batch just for you. Okay. Is there any other comments from anybody before we close up?
Yes, I've been playing with the ST microcontrollers.
Yeah,
and they're very cheap and they're crazy powerful, like 84 megahertz and stuff. And I got the STM Blue Pill. You can buy 3 of them for like $20. And I was thinking if we pair it up, and they have like 1 to 2 megasamples per second ADCs. So if we pair them up with the direct conversion receiver, we can digitize the one entire ham band at a time, and then probably do an FFT in real time and show it on an LCD screen. So and it would cost like just a couple of bucks for the screen and a couple of bucks for these microcontrollers.
That sounds like a really good add-on after the DCR project is done, and then develop something like that. That would be an interesting one, Hassan, for sure.
Yeah, that might be fun to play with. So
I'm glad to see that you haven't stopped thinking. Now start some of this stuff on paper.
Well, let me show you. Can you guys see the video?
Yeah.
I'll show you my setup here now. This is my new, and this is my kits. So,
there's your fancy.
I mean, this yeah, there's a 50 megahertz clock signal on top and like an 8 megahertz below it, and I can change the frequencies. You can see here, but it works beautifully. I mean, I had this thing for 3 years and I never really used it. It was too complicated to get set up. But then I bit the bullet, and last week I got it working over the weekend, and they're actually pretty good. So for a buildathon, they're perfect because someone can sweat through all the software setup ahead of time, and then in the buildathon, we just have these really neat boards that can just have to be, they're Arduino compatible. Like you can plug in an Arduino shield right on top, and they're easy to use. So they're perfect for that.
We did do something with the Blue Pill back a while. I can't remember what we were doing, but we were experimenting with it, and I can't really remember. I remember Frank doing a cheat sheet for it and whatnot. But anyway, okay. Thanks for that, Hassan. And Dwayne, you had your hand up.
Yeah, just a couple comments before I was looking around when you're talking about the Hack RF, the new version of SDR Sharps directly supports the Hack RF in it right now. And LT Spice, if you go to Amazon under the Kindle and take a look for LT Spice books, they have a couple of versions of instruction books on LT Spice that are in the Kindle Unlimited, so you can just download those for free. And let's see, you were looking for a VFO for the direct conversion receiver. My blog, there's a SI5351 board with Arduino Nano and a display that I made up a couple of years ago. That might be a nice little usable thing that you could put in there. It probably only costs about $10-12 for parts for it.
Yeah. Good. Thanks. Good idea. And I'll have to take a look for that Kindle book. Especially you said the price was right. Dave, you had your hand up?
Yeah, Hassan, take a look at Charlie Morris. I can't remember if he uses a ST Micro or a Tinsy, but he created a SDR radio, but it's on audio. So it's a very narrow bandwidth, but it's actually pretty cool. He uses a library, and it's got virtual cables you use. So take a look at that, how he does it. It's pretty cool. And I can't remember if he uses an ST Micro or a Teensy.
I think he used for some reason I think he used the Tinsy, but I can't remember. It's been a while actually since I've looked at his stuff. But I should probably get back to it again. Much better to do that than doing the gardening. Okay, anybody else comments?
Was that a ST Micro or Tinsy that Hassan has shown? Sorry, I missed that.
Sorry, I didn't understand. No, I think
which controller was that which Hassan was showing? Like, just wanted to ask you, Hassan, like, was it a ST Micro?
That I don't know. Anybody? Yeah, I'm not sure.
Okay.
Okay. I guess that's it, everybody. Then, well, thanks very much for coming out tonight. It's been a blast. It's been lots of good information, and it's been fun. I'm not sure of the date of our next little session, but I guess it's a couple of weeks away. I'm not sure if it's me or Eric taking that one.
Yeah, that's I'm the MC there. It's 2 weeks tonight, 29th.
Okay, and that's our other meeting type. So hope we'll see all you guys out for that one. All right, thanks so much, everybody. Have a good night, and we'll catch you up in a couple of weeks, if not sooner. 7-3.
Right. Yep. Thanks, Peter. So 8 o'clock on the 29th.
Yeah. 7-3 to all.
Bye.
Okay. Good night.